Administration of networks in Linux. Linux was built with networking support from the very beginning. Practically anything that you can do physically sitting at a computer, you can also do over the network remotely, and you can do this almost transparently. While this is a great feature for system administrators, it can also present dangers because an intruder could enter your system and do great damage from thousands of miles away. So we have to make sure we set up remote access privileges in a restricted manner so that we can control who can connect and where they can connect from. So let's get started. First order of business is to get an understanding of how networks work in general. We're going to talk about the hardware involved. We're going to talk about what routers and protocols are, like TCP/IP. We're going to talk about addresses like IP addresses and DNS addresses. Now, if all those terms and acronyms don't make sense to you, that's okay, because after the overview they will. And then we're going to talk about configuring our system so that it's accessible over the network to other computers. We're also going to learn how to access other computers from our computer. And we'll also learn how to control access to our computers so that only certain machines or certain people can access our system from a remote site. And then we're going to talk about remote system administration. So for our overview, there's 4 major components to a network. There's the hardware, there's packets, the information, there's protocols, and there's addresses. Now the hardware is just the physical stuff that's moving information around, like the routers and the wires and the cards in your computer. This is all the hardware that's responsible for making your computer communicate with some other computer. And then there's the packets, the information that's actually being transmitted between the computers. It's just broken up into small pieces called packets. And the protocols are the rules that govern how the packets are transmitted through the network. And the addresses, the origin and the destination address, helps the routers and the protocols decide how to move stuff through the network so that it gets to its destination in an efficient fashion. The underlying hardware in your network is probably Ethernet. Okay, you probably have an Ethernet card in your computer. Maybe you are hooked up on an AppleTalk network or a fiber channel network or something, but you probably have an Ethernet card. And then that card communicates over wire, and that wire is probably either a 10 base T wire or 100 base T wire. And the 10 and the 100 just stand for the number of megabits per second that can be transmitted over the wire. So obviously 100 is faster than 10 base T, 1000 base T is coming along now, and we know how quickly things move, and probably by the time I get done recording this video, 1000 base T is going to be the norm. Then after it moves over the wire, it moves to what's called a switch. Sometimes it moves to a hub or a router. But in essence, all of these things are the same. Switches, hubs, and routers. Technically, they're different, but in essence, all they are is they're boxes that have a bunch of wires hooked up to them. And when information comes in over one wire, the switch determines which wire it should go out on so that it gets to the destination in the most efficient fashion. Now, the information that's being directed by the switch is what we call packets. Okay? Now, the packets, what it is it's one big piece of information you're sending, like a picture, an email message or something, and it's broken up into small pieces called packets, and each of those packets is then sent over the network independently. Okay? So you can imagine the way the switch works. A packet comes in and another packet comes in, and it's just sort of like this stream, and the switch keeps moving them through all to their destination. Okay, each of these packets has a header in it with some information, and the information in there is like the destination address, the origin address, and that helps the switch move the packet to its destination efficiently. Now, the rules that govern how the things get moved are what we call protocols. Various protocols that are in use on the internet. Some of the more popular ones are TCP, which stands for Transmission Control Protocol. There's IP, which stands for Internet Protocol, and there's UDP, which stands for Universal Datagram Protocol. Now, these protocols are not disjoint. A lot of times you'll hear the acronym TCP/IP. And what that means is that TCP and IP are being used in conjunction with each other to do the transmission. So let's explain how a transmission over the internet happens, and we explain that through this layering diagram. Okay, so think of this column here as your client machine, and think of this column over here as the server machine that you're getting information from. Well, the request is initiated in your application layer, like your web browser, for instance. You click on a link, or you say download this file or something, and the application layer then interacts with the transport layer, which is the interface to the internet. Now, the internet interacts with other pieces of the internet through the network interface layer. And once it gets over to the machine that it is destined for, then the transport layer interacts with the application layer and the server machine and says, hey, this guy over here wants this information. Then the information is sent back like this, back up to the application layer of the other machine. Another request is made, another response is made, and so on. And it kind of goes down one column and up the other column. Now down here in the Internet and Network Interface layer, this is where the Internet protocol is used. And up here in the Application and Transport layer, this is where either TCP or UDP is used. Now what helps the packets travel from one computer to the other computer in the network are what we call addresses. Those addresses range from hardware addresses to IP addresses to host names. The hardware address is the local address. This is the address of your Ethernet card, for instance. But this is not the address that we need to know to send email to somebody or look up a web page. For that, we need host names. And host names are really the same as IP addresses. And these two things are linked together through this thing that we call DNS, the Domain Name Service. So when I type in www.cbtnuggets.com into my web browser, it goes to my local name server, which then translates it to an IP address like this. Now, an IP address is made up of 4 1-byte chunks. Each of these numbers ranges from 0 to 255. That's what makes up a valid IP address. And the numbers here, this is what's used by the routers. The routers like to use numbers, us humans like to use names. So DNS is a way to link these two so that we both can be happy. Okay, so once the router maps it to the correct IP address, then there's a mapping to the particular hardware address so it gets to the right Ethernet card. And actually there's one more step here that I forgot to write down. It gets also mapped to a particular port. So think of the Ethernet card as like the post office and the port as like a PO box at the post office. Box 25 is used for email traffic. Port 80 is used for World Wide Web traffic, and so on. Okay, if you need to start some other service, you can look it up in a book what port it normally resides on. Okay, the ports make it so that the one Ethernet card, many services can be running on that. I can have an email server running, a web server, and the ports make it so that the correct traffic is mapped to the correct service, and they can all coexist on the same computer at the same time. Okay, so now that we've given this big overview, let's move on and actually do some configuring of our system. Now there's a handful of ways to set up networking, and I'll show you a couple of them. Either way, you have to be the root user, so I'm going to switch over. Now, one of the things that we can do is use the tool called netconfig. This is a Red Hat tool. You can see it's copyrighted by Red Hat, and it's pretty primitive, but it gets the job done. It tells you down here how to use the tool. Tab moves between the selections, space does the selection, and F12 moves to the next screen. So the first question is, would you like to set up networking? Yes is highlighted, so I'm just going to hit the space bar. Now to fill out this screen, you have to know whether you're using a dynamic IP configuration or a static one. You could use either one. They're both common. Okay, mine's static, so I'm going to fill out this stuff, but let's talk about dynamic for a couple seconds. A dynamic IP configuration, what this means is that when you logged on to your ISP, you would query the DHCP server. What this stands for is Dynamic Host Configuration Protocol. You would query that server and say, give me an IP address, and that thing would go through their big pool of IP addresses and select one and give it to you for this session. So that would be your IP address until you logged off, and when you logged off, it would go to be somebody else's IP address when they asked for it. Okay, so this allows someone without a whole bunch of IP addresses to serve a bunch of people. Hopefully they have enough so that they wouldn't run out of them and you wouldn't get denied from using the system. Okay, that's the only drawback to using those. So like I said, I don't have a dynamic one, I have a static one, so I'm going to hit tab here and fill out these fields. Now my IP address that I've been assigned is 209.11.135.227. Okay, and now I'm going to hit tab here, and it filled in this field automatically. It's not always right, and it's not right in my case. My net mask does not end in 0, it ends in 248. This net mask has to do with sort of how many IP addresses your ISP has to give you in some sense. The more zeros there are, the more that they have available in some sense. Okay, that's just a rough explanation of what that is. We don't really need to know all the details there. Now, I'm going to hit tab again, and it took a guess at my default gateway in my name server. The gateway for me is actually address 225, the address they guessed for my name server. What the gateway is, though, is it's kind of like your front door to the rest of the internet. This is where your computer and all the other computers on your ISP's network, they're using that gateway to get out to the rest of the internet. Okay? And for my name server address, they were pretty far off because my primary one is 209.10.34.23. Okay, and again, the name server, the function of that is what we were just talking about a few minutes ago when we were saying, how do we resolve names and turn them into numbers? Well, that's the name server's job, and here's the address of my name server. Okay, so I'm going to hit tab and hit spacebar to say OK. And there, we're done. That was pretty easy, right? So we use this really simple tool, netconfig, to set all that up. But you might not have netconfig, and I want to show you how to do it anyway. So first, before we do that, what I want to do is go into this directory, etc sysconfig, and in Red Hat, it's also in the network script subdirectory. Oops, I have to cd into there, sorry. You probably do that all the time. I'm just showing you that I'm human too. Okay, so we go in there, and what I want to do is I want to look at the ifconfig eth0 file. Okay, this is the interface I just set up, was the eth0 interface. That's always the first one that you set up. And you can see here that I've set it up. It's static. If I had chosen dynamic back there, this would say DHCP. And you can see there's a few fields here that I filled in from the netconfig utility. Okay, so now what I want to do is I want to show you how to fill these fields in without using netconfig. And one of the ways that you can do that is with the commands called ifconfig and route. Okay, so the ifconfig command, to do that, you would say, okay, I want to set up eth0, and I want to bring it up, so I say up. Okay, and what that just means is you want to start it, okay? And then what I do is I provide my IP address, like 209.11.135.227, and then I say netmask, and then I provide my netmask, and you type that in, and then I would hit enter to set that up. Now I don't want to hit enter here because I've already set it up, and I don't want to cause some duplication and mess things up. Okay, so I'm just going to hit Control C here. But if I hadn't used netconfig, I could do it like this. And the same goes for route. If I want to add a gateway, I use the route command. I say add this default gateway, okay, and then I give my gateway address. Okay, and again, I don't want to hit enter because I don't want to duplicate some of this stuff because I've already done it, but I just wanted to show you how to use the ifconfig and route commands to fill these in. Okay, so I'm going to hit Control C again. Now, one thing these two commands don't do is set up a name server. And to do that, you can go over to the etc resolve.conf file, and you can look in there, and you'll see there my name server address is located. That's where you could set it up. If you wanted to do it all manually, you could use the ifconfig command, the route command, go over to this file and edit this line and say, okay, here's what my name server is. If you wanted to put in secondary or tertiary name servers, you could also add lines under this, and you would do it there. More and more these days, people have a connection to the internet such that they plug a wire into the back of their computer, they plug the other end of the wire into the wall, and boom, they're connected to the internet. To set up networking for those people is how we already did it with the netconfig command. But some people are still using modems to connect to the internet, and for those people, they've got to use PPP, which stands for point-to-point protocol, to connect to the internet. Okay, so let's look at how to use point-to-point protocol. And it's in user, share, doc. It's not installed on the system by default. My version is 2.4.1, so let's go into that directory and see what's there. If we do a listing, you'll see a couple README files. So if you're going to install this, it's a good idea to always read these. And then you'll see a scripts directory. And in the scripts directory is some stuff that you have to modify to get PPP to work. So if I go in there and do another listing, again, you'll see a README file. This README file tells you what all the different scripts in this directory do. Let's look at the PPP on script. If you look at the script, there's some variables in here that you've got to set up. You've got to set up the telephone number, an account, and a password, local and a remote IP, and a netmask. Your information service provider should provide all of this stuff to you. Okay? So you just fill all that stuff in, you edit the script to fill that in. If you go down farther in the script, you'll see also that there's a variable dialer script that has information on where the PPP on dialer script is located. Okay, they say to put it in etcpp, you can put it wherever you want on the system. Just make sure you change this entry once you put it there so that it knows where to find it. Okay, so PPP on and PPP on dialer work together in combination to dial you up to the internet. And it should be as easy as typing PPP on at the command line, and that should initiate your connection. It should dial and link and give your account name and password and just get you onto the internet automatically once you have it all set up. If you need help to do that, look on the internet, read the README files, and it should all go pretty smoothly. It's a pretty easy process. So now that we've set up networking on our computer, let's actually connect to a remote machine. One of the easiest ways to do that is with the telnet command. This is an age-old command in Linux, and it's on every Linux system that you'll ever run across. And then what you do is you give the name of the computer that you want to connect to, And here I'm connecting to sdf.lonestar.org. Lonestar.org is affiliated with freeshell.org, and they both give out free Linux accounts. So it's a great way to test drive Linux if you haven't installed it on your own system yet. So here I'm going to Telnet there, give them my username and my password. And there, I'm on the SDF machine, wherever that's located. Maybe it's in Texas since it's called Lone Star. So a couple of the negatives of Telnet. One is I don't get a graphical interface here. It's not like an X Windows interface. It's just a plain text interface. And also, when you type in your username and your password with Telnet, it goes over the network in a plain text fashion or an unencrypted fashion. So if someone was out there with a packet sniffer, we call it, or snooping on the network, in other words, and they could see your username and your password fly by, then they could just turn around and log onto the system and trash your account. So if you really care about security, Telnet is not the way to go. And instead, you should use something like SSH or Secure Shell. So let me log out of here and we'll look at the man page for SSH. So SSH is this secure shell, like I said. When you use the secure shell to log on to a system, it automatically assumes that you have the same username that you already have. So if you want to change that username, use the -L option and you give a login name to SSH. Okay, so the SSH connection, when it sends your username and your password over the internet, it sends it in an encrypted fashion, so someone couldn't just look at it and know exactly what your username and password is. They'd have to decrypt it, which has turned out to be quite a hard task. Right, another useful program to know about is the FTP program, which stands for the File Transfer Protocol Program. And you can tell by the name, it's for transferring files over the internet. So the basic text version of this you get to by typing FTP and hitting enter, and then you get to the FTP prompt. From here you can type any number of commands, and if we type help here, you can see all the commands that we can use. And this is a real mixed bag of commands. And when I say that, what I mean is that there's Linux commands in here like cd, change mode, ls, pwd to print the working directory, and so on. These are Linux commands, but then there's like DOS commands mixed in, like dir. Okay, and dir and ls basically do the same thing, but they have them both there so that, you know, DOS and Linux people can both use FTP. But there is no rm command to remove a file. That's a classic Linux command. And instead, there's the delete command from DOS. Okay, so like I said, it's a mixed bag. If you're trying to use some command and it doesn't work, go to the help screen and look through all these commands and find the one that you really want. Then there's FTP specific commands, things like open to open a connection to some remote site, and close to close that connection. There's put to put a file from your local site out to the remote site. And then there's get, which does the exact opposite. It gets a file from the remote site and brings it to your local site. Okay, so let's do some FTP stuff here. I'm going to open a connection to ftp.cbtnuggets.com. And then what it says down here is it assumes that my username is Perry because my username is Perry on this local machine. And my username actually is Perry on that machine, so I'm just going to hit enter. If my username was something different, I would type it in right there. So I'll hit enter, and now it says I need to give a password, so I'll type my password in, and now it says that I'm logged on. Okay, so I can do an ls command here and get a listing of that web, the fact that there's a directory here called web. I could also have done a dir, okay, and it also tells me the exact same information, okay. Now I can go into that web directory with the cd command, and I can do an ls here, and you'll see a file called index.html there. Okay. Now if I wanted to get that file and bring it to my local machine, I could do it just like this. Get index.html and bring it to my local machine in the home Perry index. I'm going to call it index 99 though on my local machine. Okay. So I can do that, and I can get that file, and it tells me there that the transfer is complete. It tells me how fast it was and how, how many bytes it was and how fast it was. Okay. Now I can also do a put here. I could put a file from my local machine out to that remote machine, and I would do it sort of the exact opposite way. I would say home Perry, let's see, I'll just put out that index99.html file, and I'll put it out there, and I'll just name it index33.html this time. Okay, so I put that out there, and now if I do a listing, you'll see right there the index33.html file is out there on the remote machine. Okay, so the FTP program is a very useful program to know about. This is the text-based version. There's also a graphical version I want to show you really quick. So I'm going to close this connection and quit out of FTP. And the graphical version is called GFTP for graphical FTP. And I run that. I'm going to put it into full screen mode here. And what happens now is here's my local home working directory. Okay, if I want to connect to some machine, I do it up here. Oops. .com, Over here I put in my username, I put in my password, and I'm going to change my password now so you don't know how many letters it is, and I'm going to connect with this button over here. Okay, so now I'm connected. There's the web directory. I double click on that, and now there's a listing of the files out there, the index 33, and so on. Okay, and now if I wanted to bring some file here, I could like highlight it and I could drag it over. I could click this button or so on. I'm just going to drag and drop. So I'm going to drag it over and drop it. And now down here it's saying, okay, the connection's finished. Here it says the transfer was complete. And if I look down in my list here, you'll see there's the index 33 that I just brought over from the other site. Okay, so again, this is a pretty self-explanatory program. Once you understand how FTP works, you can use the text-based version or the graphical version. They both pretty much do the same thing. It's just a preference of which one you'd rather use. Now, your exposure to the internet up till now might not be through programs like Telnet and FTP and SSH, but I'll bet $5 that you've at least browsed the web and sent and received email with people. And Linux certainly provides all those capabilities. One of the more popular web browsers in Linux is Mozilla, and if I click on this little red horse head down here, you'll see a glimpse of the Mozilla browser. And if you've used any other browser, it should be pretty self-explanatory. Here we are in the CBT Nuggets homepage. I move my cursor around and moves over a link. It turns into a little hand. I click on that link and I get to some new web page. I can click on the back button to go back to a previous page. I could type in a web address up here and go to that website directly. If you want to configure this, you go under Edit Preferences, and that'll give you all the information here. You can use Mozilla to read mail and news groups. The Navigator portion of Mozilla is the web browser, and one of the things I just set up recently was so that my internet search engine defaulted to Google. Okay, so check out this and configure it the way that you want it. You might have noticed over here that some text that got cut off on the side here, and all of cbtnuggets.com did not appear up here. That's not Mozilla's fault. That's not the web designer's fault. That's just because I have my screen resolution set so low for recording these videos that some things got cut off and look a little ugly. And like I said, one of the other popular things to do on the internet is to read and write email. And under Programs, Internet, Balsa is the way that I like to do it. This is a little bit of an inside joke. There was an email utility in Unix called Elm and Pine, and Balsa is just another play on that theme, the wood theme, I guess. It's a lightweight version of those. Under this, you can compose messages. You click on compose. I think that's pretty self-explanatory. You fill in the to field and the subject field and you write your message. One of the things you have to decide is how you're going to receive mail on your Linux system if you want to do it that way. And under setting preferences, mail servers is where you do that. Under the help screen, it'll give you some pointers on how to do this, and it just depends on what your information service provider provides you. Do they provide you with some kind of a POP account? Are you going to use a POP account on some other free web service like Hotmail or something? Are you going to run a mail server on your machine? And if your machine's up 24 hours a day, 7 days a week, that's an option as well. I would suggest using a POP server and setting that up if your information service provider provides that. And you should check with them, and like I said, go to the help screen over here in the Balsa main window and go to Getting Started, and they'll talk all about setting up your mail server. Now I want to talk a little bit about how to restrict access to your machine. One of the more popular ways these days is through what we call a firewall. A firewall is a barrier between you and the rest of the internet, and you configure the firewall so that you let through selected traffic. And by that, what I mean is you can let through accesses from certain accounts, or accesses from certain remote machines, or accesses for certain services, or any combination of those. Now, a great site that you should look at is called linuxsecurity.net. linux-sec.net. This has all sorts of information on this. It has information on how to harden your system to attacks. It has information on the top vulnerabilities of machines. It has little audits that you can do to make sure that your machine is not not being compromised or able to be compromised. It has tools so that you can configure SSH and firewalls, your mail server, so it doesn't act as a spam mail server. Then it's got some tools, some hackers tools. A little while ago we were talking about packet sniffers, and their information on those is right here. And I think understanding the tools that hackers use is a good security measure, because then you'll understand what you're trying to guard against. Now, another great site out there is this site called linuxfirewalltools.com. This guy wrote a book on Linux firewalls, and I'm sure you can order it on the site here. You can also get information here, and there's a great tool way down here under Firewall Tools. This program called Mason is a really cool tool. It's an interactive configuration tool. So you run Mason on the machine that that's going to act as your firewall, and then you access through that machine certain things, and it's asking you questions about what kinds of accesses you want to allow, who can access it this way, who can't access it this way, and so on. And this is a really neat thing. Again, there's more information on these sites than it would take you hours and hours to read all this stuff. And I don't think you can spend too much time on security if you have sensitive information on your computer that you're trying to guard. We were just talking about firewalls, and the benefit of firewalls is that they can block access to any service on your machine at all. Now, there's other things that you can use to block access to services. One of them is called inetd with TCP wrappers, and another one is called xinetd. This is just an extended version of this. Now, before I explain what these are, let me just say that they can block access to select services. And you might ask yourself, why would I want to use these if they can only block access to certain services when firewalls can block access to any service at all? Well, one of the first tenets of security is that you should duplicate security measures if you can. That way, if one mechanism fails, the other mechanism is there to back it up. So let's explain what inetd and xinetd are. They're what we call super daemons. Now, a daemon is some service or some server or some process that's running on your system in the background. Well, what these things are is they're super daemons, meaning they control a bunch of other services like FTP, Telnet, IMAP, which is some mail protocol. And what they do is when traffic comes in over the internet and it says, okay, I want to connect to your FTP server, instead of us running all these servers and then that traffic going right to that server, what it does is it goes to one of these two things, and then they direct the traffic over to the actual server and start this server up so that you can establish that connection. Okay, so I don't want to run all these services at once if they're not being used, right? Because that would eat up resources on my system. It would eat up RAM, it would eat up CPU resources, and so on. So instead, I just run this one super daemon, and that super daemon then interacts and starts up the service as necessary. Okay. Now, when that person disengages their FTP connection, when they disconnect, then the super daemon stops the FTP server and puts it back in limbo, and then again, it's saving resources. Now, one of these two things is active in your system. xinetd is now the standard in newer Red Hat and Mandrake Linux systems. inetd still might be active in your Linux system depending on what you have. But xinetd will be the standard soon enough. So the way inetd works is that it works in combination with this thing called TCP wrappers. TCP wrappers is basically two files, /etc/hosts allow, and then etc/hosts.deny. Now, these two files, pretty self-explanatory probably, they just contain a list of hosts that are allowed to access your system or hosts that are denied from accessing your system. Okay? Now, you can use these, you can set these up. If you have a system in both of these files, host.allow takes precedence. So make sure host.allow does not contain any systems that you don't want to have access your system. Now, xinetd is an extended version of this, and it doesn't use these files, but in spirit it's the same thing. But xinetd can have much more fine-grained control. You can control who can access your systems. Maybe you can limit who can use FTP at certain times of the day even. Okay, so let's look a little bit closer at xinetd. Before we go on and talk more about xinetd, let me just say a couple things. First, it's pronounced xinetd. So if you want to be hip, you say xinetd. Okay? And secondly, it's the epitome of why Linux is so great. The original version, inetd, was discovered to be flawed. And it wasn't flawed like it had a bug in it. It was flawed in its design from the ground up. But you really can't fault the designers, right? Because there's no way they could have conceived of the explosion of the internet and the new methods that hackers would use to compromise systems. Okay, one of those new methods is what we call denial of service attack. A denial of service attack is when a hacker gains access to many computers around the world and uses all of those computers to simultaneously attack some website, for instance. And I don't want to mislead you when I say attack. What I mean is all they do is access the website, and it's the sheer volume of accesses that then brings the servers down to their knees. And you can't discount denial of service attacks at all, because they brought down systems like Yahoo, which is a gigantic organization with a large number of servers. So if you can bring down Yahoo that way, you could bring down anybody. So ZynetD was written in response to the new internet, if you will. Okay? And the best place to learn about ZynetD is at www.xinetd.org. And you can see it was written as a secure replacement for INETD, and it was written by this guy at Colorado. Okay, that's the beauty of Linux. Then the Linux community kicked in and said, oh, okay, how about if we did this? Or here's a bug I found, and so on. And now it's mature enough that it's included in a commercial product like Red Hat Linux. Okay, let's look at some of the features of ZynetD. Here's one of the big ones. TCP wrappers are good, but can only see one connection at a time. ZynetD can limit the rate of incoming connections, the number of incoming connections from a host, or the total of number of connections for some service. Okay, so TCP wrappers, see, they only say this host can or can't access my system, but they don't say how many times in a minute or how many times in an hour they can access. So that's where denial of service attacks keyed in. Once they got access, they just pounded the site over and over and over again. And you can see down here, you can prevent denial of service attacks. If one host seems to be hogging your services, you can limit the number of simultaneous connections from that host. ZynetD has a huge number of logging capabilities. You can log start and stop times for accesses. When somebody gets denied access, you can log information like the IP address where they did it from, what service they were trying to gain access to, what time of day, and so on. So there's all sorts of information that you can gather. The more information you have, the better of a security plan you can develop. There's an FAQ on here that you can read about what questions people have typically about ZynetD. There's sample config files, so you can configure ZynetD to do whatever you want on your system. You can also learn about ZynetD from your man pages. If you do man xinetd, you'll get information here. If you page down through, you'll see different options you can use when you start up ZynetD. Typically it's started at boot time. There's a zynetd.conf, so you can configure what services ZynetD controls and so on. And like I said, ZynetD only controls access to certain services. You can make whatever services you want controlled by ZynetD. It's a very secure system, and like I said, it's the beauty of Linux. It's a form follows function kind of thing. People needed this, so they developed it. Okay, more people were interested in it, so more people submitted bugs, so it was developed quicker, and now it's a very mature code base that's included in commercial products, and it's a response to the new internet, if you will. Let's wrap up by talking a little bit about remote system administration. Whenever you're going to do remote system administration, always use SSH. Don't use Telnet, because if you're going to do remote system administration, you're probably going to type in the root password, and you don't want to use Telnet when you do that, because then the root password will travel over the network in an unencrypted fashion. Okay? Now SSH will give you a text-based login to some machine, and you can use a lot of tools. We've already talked about ifconfig. We've talked about route already, and you can use those tools certainly over a text-based connection. And I'll show you a couple more before we wrap up. You can get a graphical interface on some remote machine if you're in the same network as that machine, the same local network. Okay? Now, you might not even want to do this for system administration tasks. Maybe you want to do this just because that machine over there has some software that you want to run, and that software is a graphical software. We used to do this all the time in college because one machine in our lab had Mathematica on it, and that's a graphical math program, does some graphing and stuff like that. And it was a very expensive piece of software, so we only could install it on one machine, but we could have many instances of it running at the same time, and so we would all log on to other machines and then just get a graphical interface on our machine to the other machine. So let me show you how to do that. So to use the XWindows program remotely, and I'm going to give the example of connecting to a machine called Baker from a machine called Adams. So I log into Adams, and then I type xhost plus Baker. That puts Baker in my list of machines that I can run X on. Then I log into Baker with SSH, and when I'm on Baker, I type export display Adams :0.0. So what this does is it sets Baker's display variable to be Adams console. So then when I launch programs on Baker, then the display of those programs is sent to Adams. So I can use whatever's on Baker on Adams in a graphical format. Okay, so now let's go and look at a couple more text-based system administration tools that we can use. One of the most useful text-based network diagnostic tools that you have at your disposal is a program called Ping. And what you do with ping is you ping another computer, and then that computer will send you packets, and the program will measure the amount of time that it takes for the packets to get to you and the response to get back to them. So let's ping a computer and see how this works. I'm going to ping www.Simon-Fraser-University in Canada. So I ping that computer, and over here you can see the amount of time that it takes for the packets to get to me. And a lot of them are around 10 milliseconds. There's one in there that's like 30. I'm just going to hit Control-C now. And now we get a summary of what happened. 11 were transmitted, 11 were received, none were lost. And then we get a minimum time, round trip time, an average, and a maximum, and also a deviation in that. So that's just some statistical information on the connection. Now, when I ping www.sfu.ca and I get this back, I learn a lot of things. One, I learned that the computer at Simon Fraser is up and running. I also learned that my name server is working because it was able to translate from www.sfu.ca to the IP address for that machine. I also learned that my gateway is working because I was able to get out and get to that machine at all. Okay, so I learned a lot of stuff. Now, if I ping www.sfu.ca and that didn't work, but I could ping 142.58.282, what does that tell me? Well, that tells me that my name server is not working, because the only difference between pinging the name and pinging the number is my name server does that conversion. So if I can't ping the name but I can ping the number, that says my name server is not working. If I couldn't even ping the number, but I could ping my gateway, then that says that the computer at Simon Fraser is down because my gateway is working, my name server is working, but I can't ping the name or the number. That says that that computer is actually down. Okay, so you can learn a lot with ping if you're careful about what you're pinging and where it's at. Definitely ping your gateway and your name servers to make sure they're working, and then when you ping outside stuff, you'll learn if that machine is up or not. All right, well, let's wrap up this nugget with a little review of what we talked about. First, I gave you an overview of networking. We talked about TCP/IP and DNS. We talked about routers and addresses. And then we talked about how to configure our computer so that it was accessible to the network, and also how to access other sites remotely from our site. We learned programs like Telnet and FTP, SSH, Mozilla. Then we talked about how to control access to our site through firewalls, through TCP wrappers, through ZynetD. And the main thing I wanted to get across here was that this is a really broad topic. And if you're the system administrator of a computer with sensitive data, you've got to keep on top of this stuff. You've got to read news groups to keep on top of recent developments, tech journals, things like that. And those references that I gave you have links to all that information. And finally, we talked about remote system administration. We learned how to run X Windows remotely, and also how to the command ping. Well, we're going to touch on networks a lot more throughout this video series. This is really just the tip of the iceberg. I hope you found this informative, and thanks for viewing.